Okay, students, so let's take a look at double reflections. And reflections are actually the best transformations to really master, because as we looked at in class, if you know how to do reflections, you can create any other isometry you want. You can actually create rotations and translations with reflections. And again, an isometry is a rigid transformation, so the shape and size doesn't change. So if we know how to do reflections, we can forget about all those crazy rotation rules and translation rules. So let's take a look. So again, here's my favorite pre-image, the dart. So we have quadrilateral A, B, C, D, and it is a concave quadrilateral. And we're going to talk about intersecting mirrors, or the lines of reflection are intersecting. So the first reflection we're going to do is over the y-axis. And the y-axis, of course, is this red line here. So what I did is I reflected it over this axis here. And so to reflect over a line, all you have to do is, if you're standing here at point D and you're looking into this mirror, your image is going to be equidistant on the other side. So we're 1, 2 away, 1, 2. That's why I really like reflections. They seem fairly intuitive as far as where you think the other point should go. So they're just going to be perpendicular on the other side of the mirror, equidistant from that mirror. So again, A and A prime are going to be the same distance. And notice again the order. A, B, C, D is going this way, and then A, B, C, D is going that way. All right, so that's an opposite isometry. But if we do a second reflection, say over the x-axis, which would be right here, this blue line, then, so we reflected, say, point D here, D prime to D double prime, 1, 2, 3, 1, 2, 3. That brings us to A double prime, B double prime, C double prime, D double prime. And look, this is now going in the same order as this one. So it's turned into a direct isometry. So it's the same as like two negatives being multiplied together. A negative times a negative is a positive. Two reflections is a positive. So if you think back to that double mirror image at the start of this video, every time it gets flipped, it's back to where it was. So what does this give us? So here's our image. And the first thing we did was we reflected over the y-axis. So here's our notation right here. So again, we work from right to left. And then the second thing we did is we reflected over the x-axis. So that's what this notation is telling you. This is a composite transformation. That's what the little circle means. And we have a reflection over the y-axis done first, and then a reflection over the x-axis. So what single transformation maps us from the pre-image here down here? Well, we know that this angle measure is 90 degrees, right? This is a right angle, so if it's 90 degrees, all of a sudden, if you look, this is a rotation of 180 degrees. So if you're using a tablet to watch this video, you could just turn your tablet upside down and you'll see that this is actually a rotation of 180 degrees. So our theorem is that anytime you have a double reflection over intersecting lines of reflection or intersecting mirrors, it becomes a rotation twice the angle measure. So that's really useful to have. Okay, so let's look at one more double reflection. So here's our pre-image again. And we're going to look at a reflection over parallel mirrors, or parallel lines of reflection. So the first reflection I did is this reflection over the line y equals 2. And remember, horizontal lines, they have zero slope. They're y equals something. So here's our horizontal line of reflection. Oh, and one thing to remember is, see here I put C prime equals C. So some of you have asked me about that. So we have this point here that is on the line of reflection. So actually it doesn't go anywhere. So C prime is the same as point C. So that didn't go anywhere. So I reflected over the line y equals 2. Look, d and d prime are 1 away. And then the second reflection I'm going to do is over this next line, y equals -3. So these two lines are parallel, the red line and the blue line. So this gives me my pre-image and my image on the double reflection. And d to d prime, and then d prime is 1, 2, 3, 4 from the second mirror. 1, 2, 3, 4. So let's take a look. So we went 1, 2 to here, and then 1, 2, 3, 4, 1, 2, 3, 4. So here's our notation again, and again I did the reflection over the line y equals 2 first, so that's going to be on the inside, and we're going to go right to left, and then I did the reflection over the line y equals -3. So what single transformation does this lead us to? Well, again, we have a double reflection, so we have a direct isometry, well, an opposite isometry is the first, if you go in this order, and then it flips, so the order of the letters go in opposite directions, but then it flips back. So this becomes a direct isometry from the pre-image to this image. And what is that? Well, it's just a slide down, right? It's a translation, and it's a translation twice the distance between the two mirrors, or between the two lines of reflection. So what is that distance? If we count the boxes, 1, 2, 3, 4, 5. Let's take a look at that distance from D to D double prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yes, that distance is 10, and it's going in the down direction. So here's our notation. It's a translation, 0 in the x direction, and then -10 in the y direction. So this would be our notation for the translation. So that's all I have for double reflections. I hope this really helps, because again, if you get these reflections down, you can avoid having to memorize all of those other rules about rotations and translations and all that stuff, because once you figure out that, oh, I can do any of these other isometries with just reflections, all you have to know how to do are reflections. So I hope this helps again, and if you have any questions, please let me know.